Hello! Welcome to lesson 1.2a. We are going to be looking at solving multi-step linear equations. So right now you guys should have your modules out, and I want you to take notes as if I was teaching the lesson. But the good thing about this, you can pause it, you can rewind it, you can go back and do anything you need with these questions. So let's go ahead and start out with number 1. So please fill out the notes as I read them along to you. So it says, two students, Theo and Lance, each have some chocolate. They know they have the same number of chocolate. Theo has 10 full bags of chocolate and 47 loose chocolates. Lance has 1.5 as many full bags of chocolate as Theo, but 35 fewer loose chocolate than Theo. Alright, so let's go ahead and look at what this is saying. So it's basically saying each people have a certain amount of bags of chocolate. We don't know how many bags are in the chocolate, so we're going to put X as my variable. Now loose chocolate are just single pieces of chocolate that they got lying around. And I know they have equal amount of chocolates. So the first thing that we want to do is define our variable, and X equals the amount of chocolate per bag. Amount of chocolate per bag. Alright, so now what it wants us to do is, how many chocolates does Theo and Lance have? Show all your work. So let's go ahead and look at this and create two equations. So it says, they have the same number of chocolates, so I know that they're going to be equal to each other. They know that they have the same number of chocolate. Okay, Theo has 10 full bags of chocolate. 10 full bags of chocolate. And 47 loose pieces of chocolate. So just individual pieces of chocolate. Lance has 1.5 as many full bags of chocolate. So if the first person, Theo, has 10 bags, Lance has 1.5 times that many. But 35 fewer loose chocolate. So if he has 47 and he has 35 fewer, that means he's going to have an additional 12. So that means right here that Theo has this many, while Lance has this many. So let's go ahead and set this up then. If I simplify Lance's equations, I would have 15x plus 12. And that's going to equal to Theo, which has 10x plus 47. So then when I solve for x, what I'm going to do is get the variable on one side of the equal sign. I'm going to subtract 12 on both sides. So that means that I'll have 5x is equal to 35. When I divide both sides by 5, that means I'm going to get x equals 7. That means that there are 7 pieces of chocolate in each bag. So we were able to define the variables, and we were able to solve that there are 7 pieces of chocolate in each bag. Alright, perfect. So now let's look at this one. It says solve the following equations, verify your solution, and show all your work. Now this is how these problems differ from the ones we've seen previously. If I just gave you this, 9n plus 5 equals 7, we've seen that before. But now how this one is different, we have two variables on both sides of the equal sign. So what we're going to try to do is get all the numbers on one side, and we're going to try to get all the variables on the other. So to do that, I always like to keep it positive. So what I want to do is I want to figure out, would I have a positive variable if I minus 9n on both sides, or would I have a positive variable by adding 11n on both sides? And I would have a positive variable by adding 11n on both sides. So negative 11n plus 11n cancel, and then I have 9n plus 11n is 20n. I then just solve this like a normal problem, so what I would do is minus 5 on both sides to get 20n is equal to 2. I would divide both sides by 20 to get n is equal to 1/10. Alright, from here now it wants me to verify it, so I'm going to plug in 1/10 into each side of the equation. So I'm going to have 9 times 1/10 plus 5. is equal to 7 minus 11 times 1/10. So right here on the left-hand side of my equal sign, it would be 9/10 plus 5, which is equal to 5 and 9/10. Here then, I'm going to have 7 minus 11 over 10, which is the same thing as 1 and 1/10. And when I take 7 and minus 1 and 1/10, that will also equal 5 and 9/10. Alright, now let's go ahead and look at the next one. Same idea now. I have an x variable on the left and the right side of the equal sign. And before I begin, I don't like having fractions personally, so I'm going to clear the fraction by doing a fraction buster by multiplying each and every term by 3. If I was able to multiply each and every term by 3, these would cancel, and I would be left with 1x minus 24 is equal to 36 plus 4x. Now, I want to keep it positive. Would I keep the variable positive by subtracting 1x from both sides or 4x? So to get the variables on one side, I'm going to choose to subtract 1x on both sides. And that would leave me with negative 24 is equal to 36 plus 3x. I would then minus 36 on both sides to get negative 60 is equal to positive 3x. My last step is I would divide both sides by 3 to get x is equal to negative 20. Alright, I would like you guys to pause it right here and verify it yourselves. So go ahead and pause it right now, and when you guys are all done, go ahead and check your answers with mine. Alright guys, you should have an answer for verifying, so let's go ahead and do this together. If I have negative 20 times 1/3, that would give me negative 20 over 3. Minus 8 is equal to 12 plus 4 over 3 times negative 20. Alright, so now what I want to do is I want to combine like terms here. And if I have negative 20 all over 3 minus 8, I need a common denominator. So this is going to look like negative 20 over 3 minus my common denominator, which is going to be 3, so I'm going to have 24 over 3, is equal to 12 plus 4 times negative 20 is negative 80, all over 3. And same idea here, I want these to have a common denominator, that will be 3. So how I do that is I'm going to multiply the top and the bottom by 3. So I'm going to have negative 20 over 3 minus 24 over 3 is equal to 36 over 3 plus negative 80 over 3. So now what I'm going to do is combine like terms and have negative 20 minus 24, which will be negative 44 over 3, is equal to positive 36 plus negative 80 is negative 44, and I still have my denominator of 3. Those are equal, so my problem is now verified, and I can move on to the next one. Alright. Now looking at this one, I have all these decimals, and I'm personally don't like them, so I'm going to use a decimal buster. I look at the place value, and I see my highest place value is right here. So I need to multiply this by 100 in order to turn this 0.42 into a whole number. So I'm going to multiply each and every term by 100, and that is going to give me 70x minus 60 is equal to negative 20x minus 42. Now I have this negative 20x and this positive 70. So to get the variables on one side and to keep it positive, I'm going to add 20x on both sides. This will give me 90x minus 60 is equal to negative 42. I'm then going to add 60 on both sides, and that will give me 90x is equal to positive 18. I'm then going to divide both sides by 90, and that would reduce to 9 over 45, if I just reduce them both by 2. And then I can reduce them both by 9 to get 1/5. I can also, since these were decimals, I can stop right here or have 0.2. Alright, so go ahead and verify this one. Check your answers with your neighbor, and then we can move on to number 5. So directions. Solve the following equations. Show all of your work. So this one's very basic. It is just n over 2 equals n. So what I need to do is I need to get n all by itself. So before I do that, I'm going to multiply both sides by 2. This will get rid of my denominator, and I'll have n equals 2n. So now what I'm going to do is I'm going to subtract n on both sides. These cancel, and I'm left with n on the right side. Now when you have a mystery number and you subtract that number from itself, you're left with 0. So there's nothing more to do there. It's a little tricky because of just the way it's written, but that's your final answer, is n equals 0. Alright, so now let's go ahead and look at this next one. There's a few ways to solve this one. You can begin distributing, you can subtract 8 on both sides, or do a fraction buster. I'm going to start by minusing 8 on both sides. And when I say both sides, I mean both sides of the equal sign. So now I'm left with negative 2/3, parentheses, 9 minus a is equal to negative 7. Now I'm going to do a decimal buster by multiplying both sides by negative 3. This negative 3 and this negative 3 will cancel, and I'm left with 2 times the quantity of 9 minus a, and that is going to be equal to negative times a negative, a positive. 7 times 3 is 21. I'm now going to distribute to both terms to get 18 minus 2a is equal to 21. I'm then going to subtract 18 on both sides to get negative 2a is equal to negative 3. I'm going to divide both sides by negative 2 to get a is equal to positive 3 over 2. Alright, so now let's go and look at this one. Once again, I have variables on both sides of the equal sign. I'm going to first by combining like terms. This will give me 2b plus 10 is equal to 2 times the quantity of 5 plus 1b. I'm now going to distribute this inside the parentheses to get 2b plus 10 is equal to 10 plus 2b. Using the commutative property, I can change these places and just have 2b plus 10 is equal to 2b plus 10. Now, if you see the pattern, we can stop right here. I have the same exact equation written on both sides, 2b plus 10 and 2b plus 10. Therefore, I could stop right here. If you don't see that pattern, you can begin by subtracting 2b on both sides, and you're left with 10 equals 10, because these cancel. If you're left with a true statement with no variables, so you just have two numbers that are exactly the same, this would be infinitely many solutions. What this means is you can plug in any number into this equation and you will get the correct answer. It's similar to having x plus 1 is equal to x plus 1. No matter what number I plug in for my x's, I'll always get the same answer on both sides of the equal sign. Alright, I want you to go ahead and try number 8, 9, and 10 on your own and double check my work as we go through it. So by the time you're done with this, you should be done with 8, 9, and 10, and then watch me teach it on the next video. So go ahead and stop this video, go ahead and open part 2, and we'll begin with 8, 9, and 10, and you should be finished with those 3.